Welcome back to my channel. I am Mahendra Singh. Today I am going to cover the topic optimization technique and then application in the field of manufacturing. Decision making problem. What is the decision making? There is examples. Suppose you have to determine which ingredient and in what quantity to add to a mixture being made so that it will meet a specification on its composition. Suppose you are making a dish, so for having the delicious food, what the amount of ingredients and in what quantity to add to a mixture being made so that it will meet specification on its composition. Deciding which set of parameter will give maximum machine efficiency. Suppose you are working in a power plant, then how much should be the temperature of steam and the turbine heat exchanger pressure boiler pressure. Then these are the things which you have to decide so that your profit will be maximum. Allocating jobs in machines of the flow chart. In suppose you are doing production of a car, then how the job will flow in the machine so, so that our productivity will be high. Decision making always involves making a choice between various possible alternative. Suppose your objective is something and you want to achieve maximum profit, minimum cost, and there is a constraint, raw material having some constraint and other things having the constraint. So far by fulfilling these constraint you have to maximize your objective function. Categories of decision making problem. The decision making problems mainly categorized into two categories. One category is the set of possible alternatives for the decision is a finite discrete set, typically consisting of a small number of elements. The alternative possible alternative for the decision is a finite discrete set and consists of a small number of elements. Solution scoring method. Category 2, the number of possible alternative is either infinite or finite but very large and the decision may be required to satisfy some restriction and constraint. Solution unconstrained and constrained optimization method. Example, fabrication of fiberglass composite with enhanced strength. So what are the factors you have to consider if you want to make composite with enhanced strength? Hard will be the temperature in degrees Celsius, hardness in percentage, curing time in minute. Objective function is maximization of tensile strength. This is the example. Here data is given, process parameter, temperature, hardener, curing time. So level 1 temperature 25, level 2 temperature 35, level 3 temperature 45. Hardener level 1 1, level 2 1.5, level 3 2. Curing time in minute level 60, level 2 75, level 3 90. Experimental result, there are different 9 serial number. If hardener value is 1, time is 60, temperature is 25, then tensile test kilonewton 7.45. So these are the things. Then you have to optimize which one is the best. So for this step is determine the mean response value for each process parameter level. So for hardener 111 tensile strength optimized function is this. So we have to calculate the average for hardener 1.555. We have to calculate average mean tensile strength for hardener 222 this. So these are the things for the time. mean tensile strength for each level of time, mean tensile strength for each level of hardness, mean tensile strength for each level of temperature. Then step 2 is the find the combination having maximum sum of mean tensile strength. So the hardener should be 8.64, time should be time 8. So on level 2 hardener level 2, time level 1, temperature level 3. Hence the optimized combination of input parameter hardener should be 1.5%, level 2 you can see level 2 how much hardener is there, 1.5. Time level 1, so in level 1 time is 60 minutes. Temperature level 3, 90 minutes. Temperature 45, level 3. Category 2 decision problem where the category 1 possible alternative is finite, small number of element. In category 2 uncontrollable factor, controllable input, decision variable, and uncontrollable factor, random variable. Get a precise definition of the problem, all relevant data and information on it. Uncontrollable factor. Construct a mathematical model of the problem. Build objective function and constraint. Solve the model. Apply the most appropriate algorithm for the given problem. Implement the solution. So for the decision problem where the alternative is unlimited, then get a precise definition of the problem, all relevant data, and for uncontrollable factor, controllable input. Factor is uncontrollable, lots of random variable is there. Input decision variable is the controllable. Construct a mathematical model of the problem, objective function and constraint. Solve the model and implement the solution. Optimization model, mathematical optimization, build how type single and multi optimize objective model, static and dynamic model, deterministic and stochastic model. Probable technique to build optimization model. What are the technique to build optimization technique? Least square regression, artificial neural network, deep learning technique. Probable technique to build optimization, least square regression, artificial neural network, deep learning technique. Solve technique, linear programming, mixed integer linear programming, heuristic, meta heuristic. Basic cuckoo search algorithm. Cuckoo search is an optimization algorithm developed by Yaxin Hang and Swasdev in 2009, inspired by obligate brood parasitism of some cuckoo species by laying their eggs in the nest of other host bird. If not detected and destroyed, the eggs are hacked to chick by the host. This algorithm can be used to find the global optimum of a function. Brooding behavior of cuckoo. Each cuckoo lay one egg in randomly chosen nest. Number of available host nests is fixed. Probability of discovering alien egg is equal to PA. Nest with high quality eggs carry over to next generation. The rules of cuckoo search. Each cuckoo lay one egg in randomly chosen nest. Nest with high quality eggs carry over to the next generation. Number of available host nest is fixed. Probability of discovering alien egg is equal to PA. What are the flow chart? Start. Initialize a random population of n host nest. Get a cuckoo randomly by Levy flight and evaluate its fitness. Choose a nest among randomly with fitness Fj. Nest with high quality egg carry over to next generation. Number of available host net space, probability of discovering alien egg is equal to Pa. This is the n number of host nest, probability of discovering of alien egg, max iteration, maximum number of iteration, initialization, generate initial n host, evaluate. Step during iteration, generate a new solution, evaluate, choose a nest randomly, replace xi with xi t plus 1, abandon a fraction of Pa worst nest, build new nest with Levy flight, keep the best solution. Step of cuckoo search algorithm, objective function, begin, generate initial population of n host nest, evaluate fitness and rank egg, while t should be greater than max generation or stop criteria t is equal to t plus 1. Get a cuckoo randomly generate new solution by Levy flight, evaluate quality fitness, choose a random nest, replace j by new solution, and if worst nest is abandoned with probability Pa and new nest is built, evaluate fitness and rank the solution and find current best. Post process result and visualization. Machining of AISI 316 Allen stainless steel in idiom. Machining parameters and their label. Formulation of mathematical model, and these are the results. This algorithm is coded by using MATLAB software. We have to write the algorithm, meta heuristic algorithm. That's all about. Please subscribe my channel.